You know, the science of aging can feel like you're lost in a maze, right? Just a labyrinth of super complex theories. But what if the secret to longevity isn't actually hidden in all those tiny details, but in a simple, kind of elegant framework? Well, today we're going to explore a really groundbreaking new model that boils the entire aging process down to just three core ideas. And honestly, it might just change everything we think we know about living longer. So here's the big problem we're facing in longevity research right now. There are over 300, that's right, 300 competing theories on why we age. That just creates a ton of confusion, and it makes it incredibly difficult to figure out what's really moving the needle. And that's the big question, isn't it? We're about to unpack a new minimal model of aging that just cuts right through all that complexity. It suggests that this whole messy process is really just driven by three fundamental variables. It's a pretty radical simplification, and as you're about to see, the implications are absolutely profound. All right, so here's our game plan for today. We'll start by looking at why a new model is so badly needed. Then we'll get into the physics behind it. After that, we'll dive deep into those three core variables, see what they mean for actual treatments, and finally, discover the brand new language this gives all of us for talking about longevity. So, with hundreds of theories floating around, how do you even begin to cut through all that noise? Well, the answer might come from a pretty unexpected place. Okay, this is where a new preprint gets really interesting. A couple of researchers decided to tackle this biological problem by borrowing a concept from a completely different field, physics. It's a really elegant approach that looks for universal patterns instead of getting bogged down in all the microscopic details. So the key idea they borrowed is something called universality. I mean, think about boiling water, right? You don't need to track the position and velocity of every single H2O molecule to know what's going on. As the water gets close to its boiling point, that tipping point, its behavior is suddenly governed by just a few big picture laws. All those tiny microscopic details, they basically become irrelevant. And that's the exact same idea they're applying to aging. The model suggests we can do the same thing with our own bodies. So instead of trying to track billions of tiny molecular changes in our cells, we can just focus on a few key emergent variables that describe the overall state of the entire system. Okay, so what are these powerful emergent variables? What are the three big things that really matter and form the foundation of this whole new model? Let's dive in and break them down. So this whole complex model boils down to just three things. First, you've got damage. That's the slow, steady buildup of errors. Second, there's resilience, our body's amazing ability to bounce back. And third, you have noise, which is basically just random biological chaos. Let's take a closer look at each one. All right, let's start with the first one. Cumulative entropic damage, or, let's just call it damage. Think of this as the steady, unavoidable tick-tock of a clock. It's this linear, irreversible process where tiny, random, microscopic errors just accumulate over your lifetime. Each little error is like an independent coin flip. One doesn't really affect the next, but over 80 or 90 years, you get a lot of them. We can actually see this in things like changes to DNA methylation or the slow buildup of somatic mutations. Okay, variable number two is our dynamic stress response. A much better word for it? Resilience. It's simply our body's ability to bounce back from some kind of stressful event. Think about it like this. When you get sick as a kid, your immune system fires up, does its job, and you're back to normal in a few days. But as you get older, that same recovery can stretch into weeks or even months. This slowing down of our recovery time is a key hallmark of aging, and it's something we can actually measure. And this is where we see a huge difference between us and, say, mice. Humans are what you'd call a stable species. We have resilience. Our systems are literally designed to return to a baseline after being stressed. Mice, on the other hand, are unstable. Their resilience is pretty much flat. They lack that restoring force, so their biology just gets more and more chaotic as they live their short lives. And this is the kicker, right? This fundamental difference means that a therapy that works wonders in a mouse, an inherently unstable system, might have a minimal or even zero effect on a human, who is already stable to begin with. This could be a huge reason why so many promising results from animal studies just completely fail when they're tested in people. And that brings us to our third and final variable, stochastic fluctuations, or let's be real, just noise. This represents all the random, unpredictable stuff that happens to our biology. It's the white noise in our system. And even in a very resilient, stable person, a big enough random event, it can push the system over the edge. In fact, some models suggest that this noise alone can account for a whopping 70 to 80% of the variation we see in aging. Okay, so we have our three variables: damage, resilience, and noise. So what? What's the payoff here? Well, this is where it gets really practical, because the model slots every possible anti-aging treatment into one of three distinct levels. So level 1 therapies, these are all about boosting our resilience. And this is where most of the treatments you hear about today fall. Things like senolytics, NAD+ boosters, even cellular reprogramming. And they're fantastic. They're great for improving our health span and making us feel younger. But, and this is a huge but, according to this model, these treatments don't actually change our expiration date. They won't extend our maximum lifespan. Next up, level 2 is all about cutting down on that random noise. This is about minimizing those biological disruptions through things like having stable routines, getting consistent sleep, keeping your blood sugar steady. So you're not trying to live longer, you're just trying to make sure you actually reach your full healthy potential lifespan. And finally, we get to level 3. This is the holy grail, the true frontier. These are the therapies that go after that first variable, that cumulative, irreversible damage. This is the only level that can actually extend our maximum lifespan. But we're talking about a challenge that is just astronomically difficult. Think repairing microscopic errors across trillions of cells all at once. So after all that, what's the big takeaway? Is it the three variables? The three tiers of therapy? Well, yeah. But the biggest contribution here is something a little more profound. It's about having a new, much clearer way to talk about aging itself. You know all those debates in longevity? Is aging programmed? Is it just random luck? Is it just wear and tear? This model basically says, hey, you're all right. It's all of the above. And each of those ideas corresponds perfectly to one of the three variables. I love how the paper puts it. They say that a lot of these ideas have been floating around for a while, but as a field, we lacked the vocabulary to express ourselves clearly. This model finally gives us that vocabulary. It gives us a framework to have a much more productive conversation. And that right there is the real power of this model. We now have a new language for longevity, a framework that lets us categorize different therapies, understand their limits, and, most importantly, guide future research toward the solutions that could have the biggest impact. So what we have here is basically a new map for the incredibly complex world of aging. It makes things clearer, it organizes our thinking, but a map is only useful if we actually use it. So the real challenge now is, how do we start using it to focus our efforts? And maybe more personally, which level of aging are you going to focus on?